So far the examples of integration by parts that we've done so far, we kind of lucked out in that one round of integration by parts got us to an answer. That's not always going to be the case. So I wanted to go through a few examples where we may have to do integration by parts a couple of times. So here's one that looks similar to one that we did before. We've got x squared times the sine of x dx. So once again, let's go ahead and get this set up. So we're going to let, given our u and our dv, the hierarchy has us, detail has us doing the trig functions before the algebraic. So we're going to do sine of x dx. And then our u is just going to be x squared. Differentiate u to get 2x dx. Integrate dv to get negative cosine of x. So when we start putting this all together, we'll have u times v, negative x squared cosine of x. By the way, you guys may have noticed that I tend to rearrange this first one, the u times v. It's not just purely x squared times negative cosine of x. Conventionally, we like to put negatives and coefficients out in front of a string of products of factors. And then when we're multiplying algebraic functions and trig functions, we tend to kind of put the algebraic part like an x squared out in front times the cosine. So that's why I'm doing that. Then we're going to have minus the integral of v du. So that would be v, which is negative cosine of x. I'll do it the other way this way so you can just kind of see it, times du, which is 2x dx. So if we wanted to kind of clean this up, what I would do is I'd have negative x squared cosine of x. I'm going to bring that negative and that 2 out. So that's going to make that a positive 2. And that's just going to leave us with an x cosine of x dx. Now at this point, when we're considering this integral right here, you may note that we don't have a formula, we can't use u substitution, so this is actually another integration by parts that we have to carry out. So this is going to be integration by parts again. Now we should have some hope here because this integrand is a little bit simpler than our first one. So it seems to be getting a little bit better. So if we set up our u and our dv again, we're going to kind of use the same thing. So we'll let u be x in this case, and dv be cosine of x dx. Differentiate u just to get our dx. Integrate dv to get sine of x. And then we come back and we bring this back into our original, or our current work. So we've got the negative x squared cosine of x plus 2. And now I'm going to go ahead and insert our integration by parts now. So it's going to be, in this case, the u times v. And if it's getting confusing with all the u's and the v's, sometimes we can use little subscripts like sub 1. Might help to keep it straight as opposed to the other one that we set up above. Either way, so we're going to have u times v, which is going to be x times sine of x, minus the integral of v du, which would be sine of x dx. Okay, so I want to make note of something important here. Notice that that 2 that's sitting out in front here, I put all the rest of this second go around of integration by parts within brackets in there, because that 2 is going to get distributed to everything within there. It's a really easy spot to make a mistake if you're not careful. So especially when you're doing this integration by parts again, don't forget to be clear about if there is a coefficient or a negative out in front there, that it gets properly distributed before you're done. All right, so let's finish up the integrating here. So we're going to have negative x squared cosine of x plus, I'm going to leave everything in the brackets for now. So we've got x sine of x. The integral of sine is negative cosine, so negative cosine would just be positive cosine of x. And then we're going to have our plus c out there. And then now we'll just distribute that too, and we'll be done. So we'll have negative x squared cosine of x plus 2x sine of x plus 2 cosine of x plus c. Excuse me. So this is our final solution right here. Now, just as sort of a little side note, if you had been given something like this, and I'm not going to give you something like this on a test or even on the homework, but if you've been given something like x to the power of 5 sine of x dx, based on what we just saw here, it took us 2 integration by parts to get rid of that x squared. We would have to do integration by parts 5 times in this case. Now again, it's not something that I'm gonna test you on, but there's an easier way out for integrals like this. It's something called tabular integration. It's kind of a trick. I don't particularly care for it, so I don't tend to teach it. But if you're interested, you can read about it in the text, something called tabular integration. So consider it if you'd like, but it's not required.